and we should be live with Advent of Code 2023, day 13. Before I start reading this, I just wanted to show off a little bit that I did yesterday. I didn't finish part 2 yet. I'm still working on planning on doing that. But while tinkering with some stuff last night, and I saw people talking about how to make efficient small caches and what you could leave out, etc. I was like, okay, given the small range of data that we actually have for the challenge, because you have basically 3 kinds of characters plus a bunch of lengths that don't go over 16. And good morning, Sunco Software, nice to have you on stream. I wrote something that I think was fun, which is I did some checks and I saw like the longest number, so like in the inputs, like these numbers, the biggest number there was 16. And you can express 16 if you don't include the 0 with 4 bits, so you can pack 2 of them into a byte. And then you have the characters, which are either a period, a hash, or a question mark, which are 3 values, which you can pack into 2 bits for 4 unique values. And I was like, okay, if I put them as 1 to 3 and not using the 0, I could use a 0 value to indicate that there is no more data, so that I don't have to encode the length of the input, like this. And then that means that I can pack a whole lot of data into just a single 64-bit integer. So what I did was actually wrote some code that says generate signature, and it takes a string and a bunch of occurrences, and then it packs all that data into a 64-bit integer, and I also wrote the reverse to decode it again. So that's all with some clever bit shifting, etc. So I just wanted to show that off quickly to show that it works, and I just think stuff like that is very fun to do. So we have the input, we have 6 values ranging from 1 to 16. Then we have generate signature, which dumps out this big number, and this number has all that data packed into it. So when I call this decode signature on that same number, I get the input string as I sent it, plus all the 6 values exactly as I encoded them. So yeah, I thought that was really fun to do, to pack like lots of data into a small number. Which also means that if you 5x this, I could actually use just 5 64-bit integers to pack the entire problem set per line, and probably even make it more compact, because I could make it even smarter than that. But yeah, that's just some fun stuff. For the actual state key that you would have to generate, it would have to be for the 5x time. So this doesn't even work for that, so I would have to expand it to allow packing it into more things. And actually you don't even need to be able to unpack it, because it's just a key. So if you have a one-way hash function, that would also work, but I really liked just writing this for fun, right? And actually, I thought that this could actually have been like one of the early Advent of Code challenges. Like stage 1, all your data is packed into these large numbers. First decode those. So I think that would be a fun challenge, and then do the problem set. But yeah, Eric hasn't been that evil yet. So yeah. Now that the fun stuff is out of the way, let's take a look at Advent of Code day 13. And I'm taking a sip of my trusted cappuccino. I also updated the camera bit mask, by the way. I once made a short where I had to take like a 16 by 9 video and transform it into a 9 by 16 video. So what I did was, like, I took the same video, put them over each other, then cropped away everything except the circle for my face cam from one of them, put them in the corner, and then overlay the zoomed version of the other video to create that new video. And I actually like that aesthetic of having the circle cam, so I figured I'd do that as well. So I updated the mask, so now we have a round circle cam. It's actually quite easy. So basically, I don't know, this is a bit big. let me just shrink it down a bit. So in Affinity, I just made a large square with a circle, and I actually made a smaller variant. But my first one was giant, and then it doesn't let you zoom, so you have to specify this to the ratio of what you're cropping out. But yeah, let's not talk about that technical stuff anymore and just get on with the other technical stuff. Advent of code. So yeah. Day 13, point of incidence. With your help, the Hot Springs team locate an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. There's just one problem: you don't see any lava. You do see a lot of ash and igneous rock. There are even what looks like grey mountains scattered around. After a while, you make your way to a nearby cluster of mountains, only to discover that the valley between them is completely full of large mirrors. Uh-oh. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the valley of mirrors, you find that several of them have fallen from a large metal frame, keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk and where you're about to run into a mirror. You note down the patterns of ash, marked by a dot, and rocks, marked by a hash, that you see as you walk. Your puzzle input. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. For example, and we have a bunch of data. Okay. To find the reflection for each pattern, you need to find the perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. In the first pattern, the reflection is across a vertical line between two columns. Arrows on each of the two columns point at the line between the columns, okay? In this pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfect in the middle of the pattern, part of the pattern, column 1, has nowhere to reflect onto and can be ignored. Every column that has a reflected column within the pattern must match exactly. Column 2 matches 9, 3 matches 8, 4 matches 7, 5 matches 6, etc. The second pattern reflects across a horizontal line instead. This pattern reflects across a horizontal line between row 4 and 8. Row 1 would reflect with a hypothetical row 8, but since it's not in the pattern, row 1 doesn't need to match to anything. Wait, what? Okay. So that's tricky. You have to find where it matches up. Okay. The remaining rows match. Row 2 matches row 7, 3, 6, etc, etc. To summarize, your pattern nodes add up the number of columns to the left of each vertical line of a reflection. To that, also add 100 multiplied by the number of rows above each horizontal line of reflection. In the above example, the first pattern vertical line has 5 columns to its left, and the second horizontal pattern has 4 rows above it for a total of 4 or 5. Okay, I need to read that again, I think. Find the line of reflection in each of the patterns in your notes. What number do you get after summarizing all of your notes? Okay. So that is interesting. So this was a horizontal mirror, this is a vertical mirror, but it didn't line up exactly, did it? Yes, it did. Except, okay. So there will always be like one or more columns that don't match. So basically you need to take the input. This will be a huge file. No, that's not it. Okay, that's fairly easy. You actually need to find like the first duplicate row or column and then see if you can expand outwards. I wonder if we could bit mask these and then just find the ones. I think that would be a valid approach here. If you would, like this is bit 1, 2, 3, 4, 5, etc. So you get one number, so that each row will have a each row will get its own number, and then you can group by those numbers and see where the indexes are one apart. And that would be the mirror image. So that is funny. Like here there's a tricky one because they'll make you think that this is the mirror, but actually the fold is here. And then the other one will be... So will there always be a fold in two ways? So I think it would be this one, but it doesn't line up here. I wonder in this case, like the symmetry would be this middle one. So it's not between, but it's an actual one. Ah, okay, so this one breaks it, and then that would mean that the symmetry would be here. Yeah, okay, I get it. So yeah, I think for me what I'll do is first I'll do my bit shifting to turn every row and column into a number and go from there. I think that will be fairly efficient. Day 13, not 13, okay. Let's make this day 13. Okay. Bool test is, come on, test is true. If test, let's override the input. Okay. Did I have something for that input, but I don't remember if I did something to have like double new lines. What do I have here? As this map one that I add will be useful if I didn't do this one. Let's see, skip empty, split by white space as that, two lines. I thought that I did something recently. For which day did we have that? I made something that would just split it by double new lines. Okay. Let's just do it like this. Input, replace all occurrences. This will be, so I need to do a string replace. \r. So that will be fine. Actually, did they do a string so it can be null? Okay, that's funny. So you can do it like this to more clearly mark that you want to remove it. And then we can do, we don't get to do the two lines, so we do split by, and then we do an n double new line. To array. So this will be our maps. For our maps equals this. Oh, this is just a string array, right? Okay, string array like this. Let me just do it like this. And now we do a for each map maps. So we want to make it a list of row and columns. So we can do list int rows list int columns mapped like this, and it becomes a list of this actually. So a list of this. So we can do list int rows is new, columns is new, like this. And then we do for int I is 0, I smaller than map.length. Oh, we still need to split those actually. So we need to select lines. Like this. So that is fine. Maps.length increment I. So this one will be each row. And I can just let's do view long. Actually, it's just the values are small, so I can actually just use a Amarth Day. Thank you. Good morning. Welcome for hanging out with me. Let me just show you what I'm doing. I'm doing Advent of Code Day 13. Basically they tell us find a horizontal and vertical mirror in this. So my approach will be to turn these into numbers by bit shifting the values. That way I can find the pairs and then find the one that is closest together. So the highest number that's closest together should be the best fold. And then from there we can extrapolate outwards. So yeah, that's what I'm writing right now. So I just parse the test input. And now I'm doing the mapping. So we do, let's just do an int here. A row is 0, goal is 0. Okay, that is fine. So we do for int, let's do row index in this case. Map 0.length, and we can do row length is map length. Just have those here. Map length and a row length. I should probably call this rows because you can construe this in two ways. Do I already have that defined? Oh yeah, because it's that. Oh, Jesus. Row num. Okay. Because if I call it row length, it might be the amount of columns in a row. So I'll do it like this. Let's see. Then we do for int call index is 0. Call index is okay smaller than call num. Increment the call index like this. Interesting approach. I've done it with string comparison without any data change. Okay. Yeah, I just think that it will be beneficial for the future and it will be very efficient, I think, to look it up like this. Like when I see stuff like this and I have to compare, it's like my mind immediately jumps to bit shifting. Maybe also because I've done this yesterday. I showed it as I started the stream, where I built something to encode all of this data into a single 64-bit integer and decode it again with bit shifting. So like this. I love doing stuff like that, and I think it's a nice technique to do. So yeah, let me see. We can do const char mirror marker is at a hash sign. Sound marker is the period. Okay. So now we can do if, so we can do string raw row is map row index like this. So now we can do if raw row call index equals mirror marker, yes. Then we can do row plus equals, and then we do row index, actually 1 shifted over like this. Makes sense, and yes, part 2 defeated me yesterday. I tried to get back to it when I have time. Same here. I just spent like 30-40 minutes yesterday evening looking back at it, and I just was inspired to write that hashing function. I was like, okay, maybe I can use this for the memorization later. But yeah, it's like I got nerd sniped and just started doing that because I think it's funny to be able to have like something that raw would be a lot of data. If you just strip it down to what it actually can be and then pack it, it's nice. I told earlier in the stream that I thought it might have been a nice advent of code challenge, that you get your data first encoded into like 64-bit integers, etc., and then you have to first decode it before you can actually start working on the process. But I don't think Eric will be that mean. So yeah, if we mark it like this, it will be done. Same here, we need to do it for the call values actually. So we need to walk the same in a different way. Actually, we can do it both ways here. And this one we plus equals 1 shifted by call index. But this one will be, this value needs to be saved. Because I'm walking this way, I need to actually have a specific column number here. So what I need to do is actually something like this. New call num actually, and this will be row num. So they're pre-initialized, but I should also. Is there a way to pre-fill it? I don't know actually. I could do enumerable dot repeat 0, row num. I could initialize them like this. So now they're all filled with zeros. Call num. This means that it gets filled with the numbers, and actually I can do columns call index like this, and this will also be row index, right? And this one needs to be shifted by call index. Let's see, enumerable in the constructor. Yeah, what this does is actually it generates a range. So it will create this amount of zeros, and then it will pre-fill that list with just zeros like this. So yeah, I think this should be right. So if we encounter a hash mark, we can increase the row val, and this I can Actually, I don't need to initialize the rows because I can add them because I walk the because I walk it in the row direction. I can just say rows that add row, and here I can do row is 0. So I can, because I have the loop outside here, but I walk in a different direction here, so that way, that's why I need to access it like this. So I think this is correct. I could also just access it like this, but actually that might be, let's just keep it consistent. Even though it might not be the most efficient, it's less error prone. and I'll just do it the same like this. So I'll do row index rows like this. Boom. And now I can just take those away and I build up my numbers. So here I can do, how did I call them here? Mat.add rows columns. Right, okay. So now I can do for the test input, let me just write out the answers. So I can do for each var m in mat console.writeline. So like this. So let's do the rows first. For each, come on, for each var row in m.rows, I can just actually write out the row here. Boom. Let me see, if you don't mind my question during challenge, why not use arrays of int instead of lists? That way you could have them pre-filled with zeros and of correct size initially. I didn't even consider that. That is just fine actually. Yeah. Let's just do it like this. Good point. I need to do new. And for the type, it never gets mutated, so it's fine to just do the same here. Thanks for pointing that out. Because we want them starting at their default value, which is 0, so that's fine. In goals, I should probably do I want to print that out as well here? I need to say that we want to do day 13 first. Program, I need to change this to day 13. Let's get rid of all my extra crap here. Okay. So looking back at the test input, for rows we have 205, okay, so we can see the symmetry here. 259, then 180, then 204 instead of 205. Is that? Okay, let me see. For the top one, they want to have the column. Yeah, because they have to match. Okay, so you have to find the reflection in each pattern. Okay, so because this one doesn't match up, because you need to mirror exactly like the full length -1 at least. You can see in the columns here 82, 33, 15, 12, and then we have one left 75. So in here it's a column vertical, so you can see exactly that this is pretty useful. And for this one we have the symmetry starting here to 60 to 48, and then so this is a row because this one will have 60 and the 25 is off and the rest is off. So yeah, this one is it has multiple, but none that really work. Okay. So actually, if we want to look at symmetry, and I want to know in the example if there's always more than one line possibly missing or not, because otherwise I could just look at these numbers here and try to find the symmetry, because you always want to have the middle one and then go up or down one, and it should be symmetrical. So how do they word that? Yeah, number representation is handy even for checking. Yep. To find a reflection, you need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. Okay, perfect reflection means there can't be more than one missing, right? Or let's okay. Let's just take this and spit out the symmetry. So let's do bool horizontal. Find symmetry. How do I even write this? Let me just do it data. Reflection. Oh, they always call it reflection. Why do I have symmetry in my head? Okay. It's fine. Find reflection. So this one will just throw an exception if it won't. Let's see, int row mid is rows count, no, data that rows that count divided by 2. I mean length probably, yes. Column mid is data dot columns divided by 2. While row mid larger than 0. Do I actually? Because I need to step in 2 directions. So for int I is it can be 2 sides, right? Let me think. For I is 0, I smaller than row mid is I. And then we need to actually check if data.rows row mid plus I, and then something like this. But I need to check which side it's on first. But I will step through it just to get my head around it. Full result is I will walk over this in a sorry. Let's do it like this. Actually, we can do trim. Sorry. Let me mute for a second. Okay, that's better. Like this cough that won't go away. So this will be col mid. And this will be columns. This one will be throw new application. No, argument. It's an application exception. Argument exception. Name of data. Neither rows nor columns show symmetry. Let me just Google how you write this because it's driving me mad. Ah, it's correct. Okay, fine. Don't doubt yourself, Nick. And then we do return result. Something like this. And now we need to account for, like, there can be one off at the end, so I will need to account for both of those. I just want to find reflection returns true for horizontal symmetry, false for vertical, throws exception for non-found. I could make this a nullable actually to make it not throw an exception. That's maybe better. Null for non-found. Let's do it like this. Something like this. So this way it's explicitly set every time, which is fine. So I should be able to just do it like this and not get any warnings. Oh no, because it will be here. Never mind. Actually, no, that's not true. I need to set it to true, because if it passes this without getting this one, it will be horizontal symmetry. Otherwise, actually, if not value, something like this. Yes. Yes, this is the way. And then I also can do this actually. If not let's see, if result that has value, this is tricky. Now actually I can set it just above here. Okay. And then it will return to false, and then, okay. That's the flow corrected. Sorry for making it hard. So let's do just the first one. Bool symmetry equals m. Cannot implicitly go, okay. So let's actually step into this. So let's see how far off I am. Okay, so that is good. But this one will also always be so this needs to be +1 actually. Like this. Add watch. Boom. So what are the data row values here again? Let me just check. So the symmetry is between these. So there are 7 values here. So the midpoint is 3. So it should be that, including the 1 minus 1, right? Does this go out of bounds? Let me check. Sure, okay. So this is actually what we want to do. Plus I and the I minus 1 with 1 extra. Which is the index here. With this is the 205 then, I think. Yes, that is fine. I need to have the same logic here. Should probably write out. Oh, okay, great. Let's see. No, not set next state, but add watch. So for these, there are 9 values, so the midpoint is 4. We need to look up because there's a 1 at the bottom. Okay, so I need to figure out which way I have to look here. Let's see. How do I check that? Because there could be multiple here. Actually, I could check the outer to see what the offset should be. So I could just check the edge cases in this case. Can't I? That's tricky. Because there can be multiple cases where, let me just think how we could, what the proper way is to do this. Because you kind of want to, like, you take this one and then you reflect it to the other side. So 0, 1, 2, 3. 0, 1, 2, 3. So you need to do one less. Let's see, Kairu, what are you trying to code? Well, let me show you, Kairu. We're doing Advent of Code Day 13. That's not it. Let me see. Advent of Code Day 13. And it's a coding challenge. I pasted it in chat. Let me pin it up here. So that should be pinned. This is a coding challenge. You get a new challenge every day. And they come in 2 parts. And for today, our challenge is here is a map. And then you need to find if it has horizontal or vertical symmetry, where one of the rows can be off. So I need to find out, I wrote some code to convert every line into a number and every column into a number. And now I need to find out which of those sides is actually the one to start with. Actually, I think I know, because if data.columns.length %2 isn't 0, find out which side doesn't match. So now we need to check if on which side the duplicate one exists. So it will either be 0 plus length minus 2, or it will be 1 plus length minus 1. And actually you can still keep going that way all the way through, so it's tricky because they can craft something in a way that it won't be clear until the end. So maybe I just need to have 2 loops there. Boom, 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 boom. Basically, I just need to try both. I think at least that's what I need to do. And let me just look at this again, because I was going into my mind, I need to actually do one less than midpoint, because this one is length 9 divided by 2 is 4. So if we start at index 4 and we do 1, 2, 3, 4 in the minus range, that is fine. 1, 2, 3, 4 in the plus, but there needs to be one less. So you need to find the symmetry here and then do one less than the actual midpoint. I'm just trying to figure out in my head what the cleanest way is to actually find it out. And what I could do is just it's easy actually, I think. So I can do data.columns, no, dot columns, take, and this would be call mid sum. If equals data.columns the thing is, they can create, and it's just like, maybe I'm chasing an edge case that doesn't even exist in the code, but they could create an input where you will only find, like at the last step, which one you need to take if it's actually symmetrical. So I'm either thinking just do both, just start naively at one and just see if they all compare, and if it doesn't, do the same from the other one. Maybe that's better actually. Yes, I think I'll just do that. Boom, boom, boom. So basically that means for int I is 0, I smaller than call mid, increment I. So this one would be like data bool valid is true, data.columns I equals, so if not equals data.columns this basically this thing that I wrote here actually. And this one takes into account the midpoint, therefore if not valid, then we do the same, but call mid shifts one over, or it shifts one back, I don't know. And then we do the same. I just need to step through it to see it. Let's see. If valid, result is false. No, it's null actually. Let's do this here. and I need to step into this just to debug it for a bit. Yes. So let me just get rid of all of this. I want to add some watches here just to know that I'm inspecting the thing properly. So it needed to be 1 over actually. Let's see, 4. So I can go 5 to, and this always needs to be -1 actually. Let's see, and this one needs to be 1 more, I think, something like this. So we compare, let's see. So yes, if it would be 8 parts, this would be the midpoint, and otherwise we do this as the midpoint. So that is fine. This is actually what I want. So this is false, and then I need to do actually break. So now it's valid. Boom. Wait. I need to set this to true again. Let's go back here. Actually, let me set this to true here, because call mid has already been changed. So I need to put this. And now it's valid. So now result will be, let's see, result is true. Then if not, result will be false, because this one is the column one, and we return horizontal. So yeah, okay. Whew! Let's see. So after this we can do console right line symmetry detected, and now we can say symmetry dot value horizontal vertical, something like this. And if you do a ternary in a string format, you need to wrap it in braces, otherwise it won't work. And then I also need to, because this is probably the one where it's the row, and I need to have the same logic for the rows here. And I need to have a sub function here. So let's see. Find reflection. This will be values. And this one can just be a bool actually. Bool result is false. So this one will be values. So we can do int mid is values that length divided by 2. So if mid values. So I just call this like this, and then we go like this, fixed. return valid. Okay, so this abstracts it away for both directions. Actually, we can do result here, not valid. We do result is true, result is false. If not result, result is true, result is false, return result. Okay, so now we have our logic abstracted away for both horizontal and vertical. So we can do result equals find reflection data.rows. Right. Then we do result is false if find reflection data.columns. Result is false. We do it like this, and then we comment away this part, and now all the code is basically those few lines, and I think this is what it should be. Let's see, you should assume perfect reflection that is starting in the middle, +1 or -1. Yes, I did. Which is probably wrong, but I'll find that out soon enough. So if it's not, I will have to rethink and find one. Because what I actually wanted to do is probably group by value and then find the highest number that had the indexes off by 1, but I should probably make the largest contiguous range or something. So yeah, I'll walk into that trap in a bit. Let's just make sure that I get this to work for now. Horizontal, horizontal, and that is wrong. Great. Oh, because I don't actually let me see, this is the one. First need to check, this one is 7. So it was 7 and 8, value will be 3, so it will be, it will check this one plus this one, and then this one plus this one, and this one plus this one. So I think it's actually the one. Is it? Let's see. No, it does the 1 minus 1. So yeah, this is the good case, and this one is actually like this. So what I should do, if not result and this, then I do this step, because you should always do the other step. Let me check if my assumption is correct here. Horizontal, horizontal. Okay, that is not correct, because this one does not have horizontal symmetry, the first one. So let's step into it. Quick watch. No, actually, let me add watches here. Add watch. Okay. $180. Wait. It didn't do enough of them. checks this one. Oh, I need to make this smaller or equal to mid. Is that correct? Yes, okay. I wasn't looping enough. And this one goes outside of the bounds. Haha. Okay, what is my issue here? Wait, what? Oh yeah, then I need to change it. Do I need to change it? So for this one I need to actually step one back. Let me check if this is correct. Nullable object must have a value. Okay, getting somewhere. I should probably write it out because I think I'm having some off by one errors here. So let's just write this out. Console.writeLine. That's the thing, if you can't visualize it and see where you would be off there, it doesn't work. So let's check this. Like this. Boom. Let's see. True, logs are everything. Yeah. I like debugging, but for something where there's so many steps and states, it's kind of. Let's see here. So do console.writeLine. Uneven length. So shifting. Fine. Okay, let's see. For the first one, why is that false? Because it's the I have the not case. Wait. Let's run this again. Let's see. So in this one we have 256 up to 180 and then 205. So that doesn't go to the other one. So in then it should compare an even length of shifting. So it compares 250. Okay, so this is at least the correct loop things. So but it doesn't go long enough. It needs to go one longer there because it's, wait, let's see, uneven length. Oh no, it stops because the first one is already off, so that is fine. So it's not horizontal. And then for the second version, it compares these two, which is wrong. And then it compares, wait, what? 82 with 12. Okay, so that is wrong. I need to, okay. Find reflection. So here, actually, I need to, this needs to be incremented actually. So that is still right. Symmetry detected, vertical, horizontal. Okay, so we got there. Okay. Uneven length, then it shifts, and then it does the second range, which is fine. Cool. Okay, so now at least this one is correct. Whew. Okay, so let's go back to the problem set and see what actually the thing is that we need to do. Let's see, this pattern reflects across the horizontal line between rows 4 and 5. Row 1 would reflect with a hypothetical row 8, but since it's not there, blah blah blah. Okay, to summarize your pattern note, add up the number of columns to the left of each vertical line of reflection. Okay. To that, add 100 multiplied by the number of rows above. Okay, sure. So that is fine. So if we have a vertical, you need to have the index there. And now I also see the problem that the symmetry won't be in the middle. Okay. Pum, 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 pum. So basically what we need to do is start from the middle and try to find symmetry till we found an edge case. And if we don't, okay, so I need to change this yet again. So let's make a copy because I like working code and I'll save it there. So to do, start at the middle looking out. Try to find a reflection that repeats until the edge. So what if they have both? Okay. I have a habit of double L-ing some things. And also I need to know not only here but at what index. Okay, let me think. Wait. The number of columns to the left of each vertical line of reflection. Okay, so that will include the one that's not properly reflected if the symmetry is to the right and adding one. Okay, so this is a tricky one with all sorts of things. Because basically what we need to do is start at the middle, or actually off by one to the right. No. Yes, we start at the middle, we walk outside to see if we can find the symmetry. If not, we shift one over to each side. It can... Let me think. No, it can be as many to the side as we want. This is so annoying. Actually, no, that's not true. Because since it needs to go to the edge, you can actually start to look from one side to see if you can find symmetry on the other side. But what is enough to call it symmetry? Is like a repeating value at the edge enough to say, okay, here's a symmetry of 1. Right? Like, looking at this example, like let's say that these two columns on the right are the same. Let's just say it here. I saw one. Here, this one. This one is a horizontal symmetry. If you say, okay, these two are the symmetry, and it reaches the edge, and this is just noise. So basically that's a valid value then, right? Because there's a symmetry edge here. And you just need to find if there's a bigger one. Because it could be like this whole section. But it's not. No, it's actually this part probably. Right? Nice. This is such a tricky problem already. It would be, yes. So you actually need to find the largest symmetry. So my idea is just going from the edge, from the outer edge, from one end to the other. Just keep looking until you find symmetry and see if you can trace it down. So like, I think this one is actually a good challenge, but yeah, let's, I kind of want to take this example here. Especially since the horizontal one. And I wonder if there are ones that have both, because that would also be tricky. Because there's nothing in the text that says it can't be both, right? Let's see, they wrote that there can only be one horizontal and one vertical, as I understand. Ah, okay. To find reflection, either a horizontal line between two rows across or between, to find the reflection in each pattern. Okay. In theory, I think it could be both, but let's just ignore that for now. I copied this, so let's throw everything away. Void for now, because I don't want the warnings. Walk top to bottom, bottom to top. Oh well, left to right, left to right, right to left to find the largest symmetry. Okay. So let's just do that. For int I is 0, I smaller, that value is that length. Increment I. We don't need to go the entire way. So, and I can call this left actually. Okay, so this is the right to left. Boom, 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 boom. Ah, jeez. It's making my brain hurt already with all the relative numbers. So yeah, if values I equals values no, let's do this. We need to do this, and then for each position we compare this, and then we need to have the offset. For int offset is 0. Offset smaller than mid. Actually, it's a difference between those two. Let me think. How do I call that? And you also need to account for the odd numbering. Thanks for all the support, by the way. It's nice to see. Just trying to wrap my head around it, because if you want to find symmetry to the other side, if it's an odd number, you have to skip the last one. So bool is odd is values dot length percentage 2 equals 1 is even, and every time you Yes, you need to have an even number, and so if it doesn't match up, you need to actually jump 2. Because if it's like, I've explained, let's just get the drawing board out of here. Basically, if you have your values here, so you have 2, 4, 6, you can compare this one to this one. If that doesn't matter, you cannot get symmetry looking at this one, so then you need to consider this range. And if that doesn't work, you need to consider this range. So you need to do it in steps of 2. So even if there's like an odd number, you skip the last one looking from this side. And then you take this, so 2, 4, 6, so this will be 5 divided by this 2. So you have this one, midpoint would be 0 plus 2. No, you need to add an extra 1. So midpoint would be that plus 1 of the divided by 2, which works in both cases. Because this is 2, 4, 6, 7. So the last index would be 7, length is 8, divided by 2 is 4. So 0, 1, 2, 3, 4. No, let's see. 2, 4, 6, 7. 7 items here, sorry. 7 items, highest index would be 6. 7 divided by 2 is 3, so it would give you this one. So you need to have the minus 1 to compare, because also if it's if the length is 6, it would give you 3, and it would be these two. So it's always divided by 2, and then that value minus 1 are the midpoints that you check. I'm just wondering if it's easier to pass like extra data to the compare function to have this walking done, because you can do it like this. Let me think. So we need to consider like the other side, and then steps by 2 in even numbers. Jesus, it's hurting my brain so much. So yeah, let's just okay, wait 1 second. If I go from this side, I need to have 1, 2, 3 values here. So you need to have the mid minus 1 will be the offset. So if this is 3, it needs to be smaller than, okay. Okay, sure. So this doesn't matter. Do we count that? There's so much to do that it's it's hard to wrap my brain around, but it's like values.length minus I divided by 2, and this one jumps 2. So int mid is this. It's I plus equals 2, because we do everything in steps of 2, and then we do offset smaller than mid. We increment this, so now we have the values I. We compare that to how do we talk the other range? Let me think. Would it be no? It will be the end line. Jesus. I'm having such a hard time wrapping my head around the numbers, because what I want to do is, if this is the full length, the first time I want to compare these ranges, and the next time I want to compare these ranges, and then I want to compare these ranges. So I wonder if I need to just minus equals 2 here, because this one will walk the entire range, but I don't want to walk the entire range. I want to walk half the range and then compare the other half. So would it be, it's like the compare length would be 2 times mid minus 1, right? 3, no, it would be 2 times mid. Back, sorry, got to go away for a minute. Yeah, no worries. It's just me struggling here, trying to even do the math in my head, because it's yeah, it's causing me some. I need to, because what I want to do is walk ever smaller ranges. So if you length equals 7, you want to do 0 and compare that to index 5, because you only compare the first 6. So the midpoint here, I think that mid is 3, and then the compare that you want to do is up to 2 times mid minus 1 is always mid times 2 minus 1. I think this is the offset, right? If you compare them to each other. So that one would keep increasing them. Yeah, I think that's it. But then I just need to walk up until mid. Now the only question is, how do I write this? So it would be like for int length is values. No, let's first do mid. Int mid is values dot length divided by 2. Okay. So now we do for int length is mid times we want to do this while, so we can do length is mid times 2, and then we do while length larger than 0, right? And then we do length minus equals 2. Something like this. This would step until we find it. So this would be length divided by 2. And then we can do for int I is 0, I smaller than mid, loop. So now we do console.writeLine. Let's just write out compare index this to this. So this one would be I to this one then becomes mid times 2 minus I plus 1, right? So that would give us the indices to compare. Console.writeLine shrinking search space to, and this one be length let me just do this and then I'll just do it here, test, and then we do parsed 0, no, mapped. Sure. Okay, 0 to 7, 1 to 6, 2 to 5, 3 to 4. Cool. 0 to 5, 1 to 4, 2 to 3. Cool. 0 to 3, 1 to 2. Boom. 0 to 1. Okay. Haha. Okay, is this the same for rows? Was there an uneven number there? I don't know. 0 to 6, 1 to 4, 2 to 3. Okay. Yeah, I think this is fine. So now at least we have our mapping from one edge. And this is the left to right, and then we probably need to do it from the other side and then just invert the numbers. Yes. Jeez, this was a hard one to work out. So what we need to do here is to actually track the length of the reflection and if it's left to right. So bool from left is true. And length, actually we can just do this here. So we can do bool all okay is true. If not all okay. Bool all okay is true. Like this, okay. Else return from left length. Okay, and this should probably actually be mid because this is the one amount to the left. Mid minus 1 actually. Okay, right. Is that true? If it's no, it's just mid. Yes, because that is the inclusive count. So this will be bool from left int size. Actually, we need to just return int. Because we just need to return this one. And if we go from the other side, we just need to add the difference. So yeah, it's still a pain. Return 0, okay. If not all okay, do the same. But from the right. Okay. Also, and values that length mod 2 doesn't equal 0. If it's not number. No, that's not true. We always need to do it from the right. This is usually a sign that you should abstract it when you start copying code, but I have to do that for now. So now I want to actually inverse these and offset all the values here. So now it becomes actually int last index is dot length, comma, -1. So this becomes this minus this, and then this minus this. Right, we have that contained. Okay. Console upright line going right to left now. Okay. So we should actually start implementing this. If values I, so let me just set up some ints here, so left, right. In this case, this just becomes left. Left is 0, okay. This one becomes a right. A right equals to this. And make this stuff a bit more readable and less error prone. So we can do if values left is not equal to values right. We say all okay is false, and we break because we move to the smaller search space. Let's just take this away for now, and let's also take this away for now. Just do console.writeLine found symmetry, comma. I don't know why I keep insisting on writing this, but I like symmetry from the left with length. Okay. We do length. Now let's do the same here. This one becomes right. No. Let's just leave this I, because now we do right equals this, and left becomes this. And then we can say found symmetry from the right with length this. Okay. Whew. This also means that the result mid actually. No, it's length. Columns values to the left. Boom, and this one becomes values dot length minus mid. Right. I think that's it. I'll have to check this, but we'll be fine. And let's add this to this one as well. This one will just be mid. Find. Well, let me see. Get reflection distance from left. for the columns, do we need to have the row or the column? Let me see. To left, above. Okay, so yes, this will both give me the right number for both versions, so that is fine. Var rows R is var C is. Let's see what it spits out here. Let me just dump this out. Found symmetry to the right with length 6, values to the left 4. Find symmetry from the right with length 8, values to the left 5. Oh my god, I think that's actually correct. Right? But no, wait, it has the same... It's testing the same thing here. So how come it found symmetry? So it did first the rows, then the columns. So for the rows, it should be 1, 2, 3, right? But was that even a symmetry? I think so. Let's see. Oh no, here was no symmetry here. Okay, let me check this. Okay, I have to debug this again. Set next statement. Ah, it didn't run. Okay, let me just set a breakpoint here and run it again. Okay, let's see. So let's see that we see what it is comparing here. And let's also do like a string.join comma values. So in this case, it's comparing 205 to 204. Boom, not correct. Oh wait, what? Wait, what happened? Okay, okay, set next statement. This is not correct, so it breaks out of that one. All okay is false, length minus, so it becomes 4. Ah, okay. Okay, I need to do this loop in a different way. Let me see. Let's see, if length, this is so messy. We can do it like this, because this will mean that it will keep looping. Okay, let's try this again. It will give us 3. Okay, this is weird. Set next statement. Okay, let's see. I will have the same issue here, right? this, and we need to have the comparison here as well. Left, right. Should probably just leave this here just to debug that. Okay, let's try again. Now we have 0. Okay, and now we have 4. Okay, great. Sheesh. Okay. Okay. Getting there, getting there. Let's see if this works for our code. Then we get symmetry. Now symmetry. Symmetry is true. Else if can do it like this. And this one be m.rows, this one be m. Okay, what's the issue here? Ah, okay. Okay. Int r and c. So we do here. R equals this if r larger than 0, else c if c larger than 0, set to false, else this. Okay. Getting there. So this should never be null, but let's run part 1 now. So vertical and horizontal, I need to remove a lot of console write lines. This one can go. Let's just should probably still debug those cases, but I kind of just want to have it 1 to 6 to 5, 3 to 4, yeah, so that is fine. Now going from the right, does it have go from the right somewhere? No. Okay. So I'll probably have to debug that as well, but for now it's fine. So now we need to keep a running total. So go to part 1. So we do long result is 0L. Plus equals, and what did we say? The rows was times 100 or not? Number of columns plus that by 100. Okay. Let's see. So I just read it and I still don't remember. Number of rows. Okay, times 100. So rows times 100. R times 100. Result plus equals C. Console, that right line. Part 1, and this one will be result. 304. Okay, that's not correct because it's 405. So they're off by 1. 5 columns to its left, 4 rows above it. So this one actually, apparently it's +1. Oh, wait. I need to get this one. Strange, I think. And this one isn't. Yes, it should return this one actually. $405, but I'm doubting this. Okay. Let's just run the real input and see what we get, just as a Hail Mary for now. I just fear so many off by 1 errors. Let's see if this works. Yeah, it's too high. Dang it. Okay. I was afraid that would happen. So let's just spit out all the data. Let me just set a breakpoint and then just compare every one of them to make sure that I have it correctly. Let's see. Midpoint is 4. So this one says it has from the right. And are we talking columns or rows here? Let me see. Call stack. So this is rows. Okay, so this is the, yes, and it says here that at index, I think it's 8, right? So it has 9 in the left side of the reflection. Does it go up to, is it even symmetrical here? 19, 56, 58, okay. So it found the reflection, I think. Because it went from the right. Let's see. So the answer here should be, it found a reflection here between 9 and 10. So there should be between 8 and 9. So the answer should be 9 what it returns. So let's see, it has this -6. So this one is 9. So this one is correct. Okay, so I think we can trust this one. Let's debug this one. In this case we have rows again. Where's the symmetry here? Because I don't see it here. It would be this one. So it's a very small symmetry of 2. So that is fine. Ah, this one is off. Found the symmetry here, and the answer should actually be 2. So why is it +1? And why is my test answer? Okay, let's go back to the test, because it should actually have returned mid there, which is fine. Test is true. Let's debug this. Ah, it says 4 or 5. Okay, sheesh. Never mind. I was playing myself and lost. The index from 1 not 0. Yeah. But my +1 there was just not needed. Woohoo! The code was actually correct. I just had a stupid mistake when I tried to fix the debug because okay. Ah! Okay. Okay, not the prettiest code. I have a lot of stuff to clean up, but we got there. Let's try and see what the trick is for part 2. You resume walking through the valley of mirrors and smack! Run directly into one. So I think this is what I thought it would be at the start, would be to detect where the fallen mirrors are based off that. But yeah, let's see what they say. Smack! Run directly into one. Hopefully nobody was watching, because that must have been pretty embarrassing. Well, if you think that was embarrassing, try looking at me figuring out off by 1 errors, etc. Ha! Upon closer inspection, you discover that every mirror has exactly 1 smudge. Exactly 1 period or hash should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. The old reflection line won't necessarily continue being valid after the smudge is fixed. Okay. That's annoying. The first pattern smudge is in its top left corner. If the top left hash were instead period, it would have a different horizontal line of reflection. Let's see, if the first pattern smudge is in the top left corner, yes, it would have a different horizontal line of reflection. When the smudge in the top left corner, with the smudge in the top left corner repaired, a new horizontal line of reflection between rows 3 and 4 now exists. Row 7 has no corresponding reflection row and can be ignored, but every other row matches exactly. Row 1 matches 6, 2 matches 5, okay. In the second pattern, the smudge can be fixed by changing the 5th symbol on row 2 from period to hash, okay. Now the pattern has a different horizontal line refraction between rows 1 and 2. Summarize your notes as before, but instead use the new different reflection lines. In this example, the first pattern's new horizontal line has 3 rows above it, and the second pattern's new horizontal line has 1 row above it, summarizing the value to 400. Okay. In each pattern, fix the smudge and find the different line of reflection. What number do you get after summarizing the new reflection line in each pattern of your notes? Okay. So this is really annoying. Because this used to be the virtual reflection, and now, wasn't it? Let me think. Oh no, it used to be like this. Right? Yes, it used to be a column reflection like this, I think. Yes. So you go from a column reflection to But the thing is, do I understand the issue well enough right now? I wonder if they made it that the differences are large enough. Because, going back to the values, that is annoying. So what did they do? They changed this one to a hash, right? Let me see. Oh, they have a different example. No, the above example again. Ah, yes, it's the formatting like that. So if they change this one to a period, it breaks a symmetry. And then it creates another symmetry. Let me see. I mean, I can. You can do this in a few ways. You can brute force it, which is just a very big search space, so that's not possible. You could do the diffs there, but I need to have a bit mask diff. Is there a simple way? C# count bit difference between true values. Let me see. It's not loading. I wonder if there's a shortcut, because I could like match every bit, shift them to the right, and that's annoying. More people from Advent of Code? No. Sum of bit differences among all pairs. Simple solution around 2 loops consider all pairs 1 by 1 for every pair count bit differences. Tja. Brute force is always an answer. Not for yesterday. I made this one yesterday. So I actually ran the brute force for yesterday, but I also did the math, and it's like 2 to the power 64, so it would never complete. But it was fun to fill up the memory of my PC. So let me think. Basically, I would allow the bit difference. So what I can do is int. It's actually a byte, but it doesn't matter. Bit difference. Int int b. Okay. Byte diff count. Or diff is 0. Diff. So for int I is 0, I smaller than 32, increment I. If A shifted to the right by I and 1 equals 1, so we can do bool BA is this one. Like this. BB. If BA not equal to BB, increment diff. So this will count the bit differences. The thing is, I can only ever change one. Yeah, that is fine. I can compare line by line. But if I have used it, it's no longer valid. Okay. So I can probably, let me copy this again. Let's see, get this reflection, this one on the left with max bit difference. Okay. Int max difference is 1. Let's throw all of this away. And now we need to, instead of this, we need to have a byte diff. So we do diff, come on, diff equals bit difference between values left, values right. And now we do if diff if diff equals 0, this case is fine. Else if diff equals 1 can happen, and then we can do a running diff count, running. Diff count is 0. So then we can do if running diff count larger than max difference exceeded amount of values that can be different. Okay. So this can account for slight differences, and there's another else case here. Too many differences. Okay. So this is the new logic. And I need to do the same here. Running diff count is this. Okay. Yes, this will loop to all of that. That is fine. We need to remove this one, left versus right. Okay, and now we should have an algorithm that can find the distance actually it needs to be, the running diff count needs to be 1, otherwise it's not valid. That's annoying. Else if running diff count equals max difference. Else. Boom. I forgot about that. It needs to actually be this diff count or it won't be correct. Oh man. Like this. Can shortcut it like this. Let's do it the same here. Not equal to max difference. Oh, we should call this expected difference. And this. If it exceeds, boom. Otherwise, it's fine. We reset it. Okay, let's run this for the test input and actually call this for part 2. Man, I've written so much code here, all of which not a lot is used. Let's see. Allow difference. Okay, like this. Let's get rid of all of this. Clean it up at least a little bit. Required difference. Like this. And this one be part 2. Okay, let's see. So part 2 we get 400, okay. Oh! Wait, what? New horizontal line has 3 above it, the second pattern's new horizontal line has 1 arrow above it, summarizing the value to 4. Okay. Okay, I didn't expect it to work right away, sorry. False. Let's run this. Woo! Part 2 in the bag. Yes. Ah, I really thought that part 2 would throw a big wrench in the... No, I'm happy that that worked. So they crafted the input very well to not have all sorts of edge cases. Classy reaction to why does it work, right? Yeah. Yeah. But it's probably because, like, in the beginning, remember trying to figure out how to step through this. Thank you for the congratulations. It's I really appreciate it. It was because of this period where I was trying to figure out this whole logic of how to step in a proper way that was so painful to figure out that kind of messes with the confidence in the rest that you write, because you're like, if I can't figure out something simple like that, how do I make the rest work? Okay. Find the amount of bits that differ between 2 values. Okay. think that is fine. Let's move it below the actual constructor here. Ever similar? No, smaller ranges. Okay. Do you have any questions about anything that I've done? Question everything? No. Is there anything that you would like me to go over? I'm happy to look at it. And if you've done your code, feel free to paste the link in the Discord. Let me see. I have a Discord where I share the stuff, and it's easy. I think it's in the video description, right? If it's not, let me know. But yeah, feel free to share a link in the Discord, and I'll happily take a look at your code if you want. I'm just going over this for now. Let's see if there's anything that I need to change. I think this is all fine. The only thing that I would like to do is, I think for this one, the left, right. Yes, it's like it's the same walk except with an offset. So I would change this to be 1 where you specify an offset of 0. Let's see, congratulations. No, I've done pretty much the same thing but with strings. Okay, nice. Your solution may actually be more elegant. Thank you, always nice to hear. Yeah, like for me, reading the problem set, like comparing stuff, this just screams to me like bit shift, like a bit shifted value, and they are easier to compare. And even like the numeric, when you check it, right? When I did the quick watch on the numeric values of the rows and columns, it just reads visually. It's really nice to spot differences in numbers versus like these strings, because it's easy to catch an off number here, right? So yeah, let's see if there's anything else that I need to clean up. This is not here. Because basically this walking logic, it's the same, except the left and right positioning is done with offsets here. So here it's so I'm not going to do that now, I think. Just want to see if there's anything else that I need to clear up for now. Shrink search space. Found symmetry. Yes. Actually, I think. Yeah, this one was also fine. Fine reflection. Oh, this one was fun. So I think I'll just delete this one. Is it still used somewhere? Yeah, I have so many of these copies of the yeah, so I can just delete this piece of code here. Boom. This one is not used here, right? Yeah, it is. Sorry, my bad. This one is also not used. So I can just throw this away. Because this one started to look from the middle, and yeah, that's just not enough there. Just cleaning up a little bit. So yeah, I think this is fine. I'll just clean this up a bit, put it on Reddit to show how I did it, and then continue with all my other work. Oh, this is funny, why did it do this? Remove and sort your key. Let's see if it still runs. Yes, okay. Is it still the right values? 3761, yes, okay. 956. Okay, I think that's it for today. It was a fun one, a bit challenging but fun. So I want to thank everybody that kept me company, especially Amartha Day. Sorry for butchering your name, but it was nice to have you here and chat. I'm doing this again tomorrow, so if you want, feel free to drop by. Subscribe if you haven't subscribed yet, so you get a notification. And yeah, thank you, and see you tomorrow. Okay, you posted a link on Discord. Let me quick. Okay. So you need to hear my code here if you want to have a look. Yes, it's always nice to see other people's code. Just one reminder though, they always ask you to not post your inputs here. So I would add those to the git ignore and maybe have that like in a private repo. But yeah, that's just a small note there. This is cool. You have custom attributes to help you with the Advent code stuff. Use live data in debug. Nice. Let's see, test file, sure. By the way, if you want, nick.youtube, and if I could spell nick.youtube, I have a video that actually helps you have some code, and it links to code as well, that will automate getting the inputs for you. So if you look at my code, you see I have a base class that says day 0 with the base with the number here. This actually pulls in the data from Advent of Code with your login session, and it adheres to all the rules that they made for automating this, so you can just use that. So basically I never touch the input manually, only for the test input. And when you do this, you will just have a variable called input available to you, which is a string representation of the data. So that's maybe something you want to take a look at. It's a nice thing to have, so you never have to do stuff like this. Let's see, get patterns. The string patterns, string is now empty. Okay, so yeah, you walk the input, and if you encounter a blank line, you use that as your separator. That's good. Part 1, get patterns. Nice, we'll have a look and steal it. Yeah, sure. Can highly recommend, it's really nice. Let's see, patterns 1. What was the pattern class here? Let me see. Reflection, vertical reflection with smudge. Okay. So the constructor here does immediately do the find reflections. Let's see, it walks all the inputs. Reflection field is false. I plus 1, plus 2 is I. Okay, input.count. You assume it's the smallest one and then you grow, or what? Let's see. Input smaller than, post smaller than, input.count to larger equal to 0. Okay, so this is a combined look that expands both ways. Okay. But it will, okay, this is interesting. Let me see. So you start at having like index 0 and 1. And if they don't match, it's failed. And if it's failed, you return, because we start at 0, you need to add 1. So that's right, it starts from 0, walks to length minus 1. Okay. So couldn't there be... Because this starts from the smallest one. So if there was like a smaller result that falls within a bigger repeating pattern, wouldn't this cause an issue? So like if 0 and 1, indexes 0 and 1 are symmetrical, then it would grow. I'm just trying to see if there's like a symmetrical pattern that could exist within a bigger symmetrical pattern that would cause you to find the smaller one and then stop, because then one would break. It's interesting. Find reflection with smudge. How do you do the smudges? Okay, you diff the characters. Okay. Yeah. Rotate pattern. Is this I see reflection false doesn't break out the loops, it would find us in. Ah, okay. Rotate pattern. Rotate strings 90 degrees. Okay, why do you do that? Is that for the easier... Oh yeah, because you have to do the column stuff. Yes, okay. Okay, cool. It's also very short, very readable. It just breaks in a double loop in case the symmetry is broken. Okay, nice. Nice job. How long did it take you to write it? Because this looks, except for like this loop here, I think this is probably the most complicated part in here. It's it reads very well. Like my code reads like a big struggle. Right? Your brain hurts just looking at it, but yeah. It's nice. It's I didn't even think of about keeping it as a string format. But yeah, thanks for sharing your code. It was nice to have you here. So if you have time tomorrow, maybe check in again tomorrow. I'll end things for now. So